Hello, algebra students. This is Mrs. Palmer, and I'm going to talk a little bit about how to solve fractional equations using some of the skills that we've been working on in algebra class. We've been solving lots of equations this year. Now what we get into is how do we handle when our equations have fractions in them where there might be numbers in the denominator or variables in the denominator, polynomials. So we're going to see a variety of those in this presentation. So first here, we have a fractional equation that just has numbers in our three denominators of these three fractions. Something that we've worked on a lot is the concept of the least common denominator. So for this particular situation, I hope you're looking at 8 and 5 and 10 and thinking that the least common denominator would be 40. That would be a really good choice. Also, another thing that we would think about would be restricted values, but there wouldn't be any here because there are no variables on the bottom of our fractions. That's something we're going to see with some other questions. So the best way, I think, to tackle these questions is to choose to multiply through the entire equation by your least common denominator. Now this is by no means the only way to do these problems, but it's a great way to do these problems. So what I'm going to do is I'm going to take a 40 to every single term on both sides of the equations. And that might seem a little strange, but watch what happens. So I end up, whoops, let me try that again. 40 times 7y now over an 8 minus 40 times a 3y now over a 5 equals 40 times an 11 over a 10. So we didn't change the denominators. That's really important. When you're multiplying through by the LCD, it's the LCD over a 1. So the denominator stays the same. But what you're going to see that's so great here, let me just get a different color, is that 8 goes into 40 5 times. We knew that. 5 goes into 40 8 times, and 10 goes into 44 times. So what's happened is we've created a situation where all the fractions are canceling away. So now that is 35y minus 24y when we multiply equals 44. Collecting our like terms here will give us 11y equals 44, and dividing will give that y equals 4. So we get one answer, and because we didn't have any restricted values, we don't have to worry about it conflicting. And as always, you would want to make a quick check to make sure that that would work out by plugging in 4 right there and plugging in 4 right there and working the problem out and making sure that you do get a viable solution. All right, well, let's look at another equation. Okay, this one has variables in the denominator. So let me get rid of this. So that's going to change the way our LCD looks for sure, but not the process. Our least common denominator here is going to be a times a plus 1. Oh goodness, a times a plus 1. Having a little pen problem here. So that's our LCD. And we also, because we have variables on the bottom, have an issue with potential restricted values. I mean, they definitely are restricted, but we may or may not need to worry about that. So we would not want a to ever be 0 here. We would also not want a to ever be negative 1. And just as a reminder of how that works, those are the numbers that if we were to sub in, we would get 0 in our denominator, which we know is a big no-no. All right, so we are going to multiply through by our LCD. Here's what's going to happen. This term goes here, here, and here. Remember, it has to go to everything. So that's now 4a times a plus 1. For a plus 1. And then this is now a times a plus 1 over a equals now an a and an a plus 1. So you can see what happens switching our colors back again so we can see the contrast here. The a plus 1's cancel. The a's cancel, and now we have something that doesn't have any fractions in it anymore. So that's now just a 4a minus, careful, minus something in parentheses, so minus a minus 1 equals a squared plus a. So giving you a second just to make sure you see how all of that works, and then hopefully you remember all of your great skills about collecting like terms, and then when you have squared terms, we're going to need to try to factor this. So I'm going to move everything over to, and there it goes again, I'm going to move everything over here. So I'm subtracting a 3a and adding a 1. So when I do that, I have nothing on the left-hand side because see, I moved everything, equals a squared minus 2a plus 1. Now take a look. That's going to factor a minus 1, a minus 1. And because my factors are the same, I get the same answer twice, so I really don't have to write it twice. It's going to give me a equals 1. Now, before we get too upset and think, oh no, we have a restricted value, we don't. Our restricted value was negative 1. So positive 1 is fine. And in fact, doing a quick little check, subbing that in, you can see you're going to get 2 minus 1 is 1. So we are good to go. That is a great answer. All right, so continuing on. For one like this, very similar to the last question, but I hope your mind automatically tunes into the fact that you want to factor down here. As usual, we always want to factor anything first. And then when I do factor that, I can more easily identify my least common denominator here as 2 times x minus 4. So again, LCD 2 times x minus 4. And I only have one restricted value, x. I don't want it to ever be positive 4. So I'm just writing that stuff up there to keep it straight in my head. Now I'm going to multiply through by my LCD. 2 times x minus 4. Taking that everywhere, all the way over there. This is what I get. You know, you get 6 times 2 times x minus 4. It is fine if you want to call that 12 right away. That's okay. I just want you guys to see for sure what's happening and where everything is going. So that is just a 12. Hey, right here, when I multiply on the right-hand side, I have a 0. So, hey, that's nice. That whole thing just goes to 0. So then when I simplify, my x minus 4's cancel. We said that was a 12. Okay, well, gosh, all of that cancels with all of that. And I'm starting to get a little concerned here. Ooh, okay, so that's 13 equals 0. Well, the first thing I do when I get a result like that is kind of say, hey, did I do this right? Did I mess up? Did I pick the wrong LCD? Did I multiply wrong? Any of that stuff. And as I look and I'm double checking my work and I say, no, it looks like everything came out okay. Well, this is not true. And if that's not true, that means there's no solution. Okay, there's no solution to this one. And just as another note, had I actually gotten an answer and had that answer been 4, ding, 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 up here, had it been 4, I would also have no solution because 4 would be restricted. Okay, so a similar setup where I need to factor first. Remember, guys, in these presentations, you can always pause if you need to think something through a little bit and then restart. So my LCD here would be n minus 2 times n plus 2. Great. I hope everybody's doing a good job with that. Now, I would have 2 restricted values. I would never want a 2 or a negative 2, so that's something to keep in mind. So multiplying through by n minus 2 times n plus 2. I hope you're getting the hang of this, so we're just going to go through multiplying n minus 2 n plus 2 to the top. Remember, the bottoms don't change. I might have to be extra careful here. We'll see about the subtraction. Always cautious about subtraction. And we'd already factored that, so it's better to leave it in its factor form. Oh, okay, hopefully you guys can read that. Equals 0. Now again, equals 0 because something 0 stays 0, which is nice. That's a common mistake, though. Lots of students want to change that. So canceling, reducing, what reduces? All right, so now it looks like I'm going to have to multiply those two things together. That's n times n is n squared minus 2n plus 1n minus 2. That's our good friend, the FOIL method. Minus 10 equals 0. All right, putting everything together here. Okay, that's a 12. I'm going to rewrite it since my pen is being difficult here. Okay, so then that we need to factor. It factors easily, I hope. And that tells us that n equals 4 from this factor, set it equal to 0, and n equals -3 from this factor. And a quick check to make sure that these answers that I just got do not conflict with my restricted values, and they don't, then I feel good about them. Okay, so let's keep going. All right, so a little more factoring here. Now no 0 on that side. All right, so factored out, I can now see that my least common denominator, they both already have an x minus 2, but I also am going to need an x minus 1. And that my restricted values here would be I can't have a 2 and I can't have a positive 1. So I'm going to keep that all in mind as I go through this problem. So multiplying through by x minus 2, x minus 1. I'm going to get 5x times x minus 2, x minus 1. Now some of you might feel confident skipping this step where I write it all out. That's okay, guys. Just make sure that you are doing it right. Sometimes we get a little anxious to speed up processes that we might not quite be ready to speed up. So just take it easy and relax. And when you're ready, you can do that. Okay. So now, again, grabbing a different color so you can see the canceling process. All right, so now that's going to become 5x squared, because I'm distributing right there, minus 5x, minus just a 6, because everything else canceled. Now over here, we have to FOIL that out first before we distribute the 5. That's the best thing to do. So that's going to give me minus 3x plus 2, and then I'm going to take the 5 in. So that now equals 5x squared minus 15x plus 10. Okay, so now, well, there's something here that definitely pops out at me. I hope it pops out at you too, is that these 5x squareds cancel. You have 5x squareds on each side, so they're definitely gone. I'm going to add this 15x over here. That's going to leave me with 10 x's. I'm going to add this 6 over here. That's going to leave me with 16. So when I divide both sides by 10, I'm going to get x is 16 tenths, which will reduce to 8 fifths, which I can also call 1.6 if I want to. But remember that 8 fifths is fine. We don't have to convert to decimals. And that solution works out. So don't be nervous about fractions. We always tend to be a little nervous. But check your answer. Make sure that it makes sense and that it works. And then you can feel confident that you have the right solution. All right, well, that is it. I hope that this helps. I hope that it gives you some more examples to look at. And I'm going to close out.